Alright, hello everyone. Welcome to this course, software engineering. So make sure you're in the correct classroom. It's for this SWE 6623, software engineering, graduate version, not undergraduate. Okay. Alright. So let me first introduce myself a little bit. So my name is Chow Mei, and my office is on the third floor. My office hour, usually you can you can walk in during this Tuesdays, like 2 to 3:30ish, or somewhere around the noon. Okay, or you can, most of the time I will be here probably in the Thursdays. So if you want me to meet me during Thursdays, it's preferred that you send an email to me first to make sure I'm there, because I may have a meeting something there on Thursday. Okay, so in order to not waste your trip, please send an email to confirm that I'm there. Also for the online student, this course is listed together for the hybrid version and the online version. Okay, for the online student, we can meet for the virtual office during the virtual office hours. You can call me in my office phone here, I listed here, or we can communicate through email, D2L, any way you want. Okay, all these lectures they're recorded because I'm gonna upload this lecture to the online student as well. Okay, for this hybrid version here, we are supposed to have 5 students today here. We have a 4 here. It's 80% appeared here, so not too bad. Okay, how do we do the hybrid version? Is that we're gonna meet once every week, and for the other part, maybe it's a Tuesday, Thursday schedule. For the Thursday part, you will finish all the assigned readings, all those materials online through the D2L. You finish all those readings, those materials online. All of your materials are identical to the online student, so you have the access to all the course material with the online student. Plus, you can meet me every Tuesday. And since we only have 5 students here, please present here. Otherwise, it will be so awkward for me to speaking to the air. Okay, don't do that to me. Okay. And email. I'll check my email regularly. If you have any question, send me email. Shoot me email. And for this course, we will have a midterm exam and a term project, which took the majority of the grade, 60%. And we will have one small research project, because this is a graduate level course, right? We will conduct some research. Maybe it can be some reading, some summary of research papers. It could be that way, yeah. And we also have some small quizzes that we may do that online, all of them online. And also the participation is 10% here. That's how I make sure that I do not speak to the air, because we only have 5. Okay, please keep that in mind. All right. And if you want to skip some of the classes due to some other reason, you can talk to me beforehand. Usually it's okay, yeah, if you have a reason there. All right. Okay. Yeah. And the grade conversion to ABCD is similar to what you already know. It's 90 above, it's A. 80 above, 80 to 90 is B. And for graduate student, you shouldn't get a C or F, because that's a graduate level course. Okay, that doesn't mean like I will give you from B above. That means, I assume you basically have the level of B, but if you're doing good, meet all the requirements, probably you'll get an A. But if you get a B, that means, yeah, you're doing okay. Okay. Well, if there's not a big issue, big problem, you won't get a C. Well, if there's a big issue, that's how you get a C. But usually it's B or A. That's what my expectation to a qualified graduate student. Okay. So in my course, I want everyone to not worry about the grade too much, because the grade is something you will not take with you forever, right? You get the A, you feel happy for 2 days, and that's it. You have a record A there. But what's gonna be with you? Your skills, the knowledges, the skills of communication, maybe teamwork, and the knowledge of the software engineering, the vision you see in this industry, in this subject, that will be with you for years, right? So that's the most important thing. I want you to focus on how can you get as much as you can from this course instead of the grade. So do not worry too much about the grade, because I assume every qualified graduate student will have a B and above, okay? Unless you messed up something, okay? So, but please focus on the the knowledge, the skills, to learn as much as you can, okay? And homework and the assignments, we will submit everything through D2L, and you please check the D2L announcement regularly so that you know what we're going to do and you don't miss any important message from me, right? And for online students, they need to take part in the online discussion, in the discussion forum through the D2L. And for the hybrid class student, I still encourage you to take part in that discussion, okay? Because it's not fully face-to-face session. It's a hybrid session. So yeah, I'm still having that expectation to you, the hybrid session class student. Okay, and the format of the assignments. Please read that part. How do you format your assignments? And this is basically a schedule for the course. We will have 16 weeks for this course, and actually it's 14 weeks for this course. 16. Well, it should be 16 weeks. There's something wrong here. 3, 4, 5, 6, 7, 8, 9, 10. Well, okay, here it should be 11, 12. 11, 12. That's 16 sessions. And every 2 weeks we will learn a unit there. So in the D2L we will totally have 8 units there in the D2L. So that we will focus on every unit every 2 weeks. Okay. And for this course, it's called software engineering. It's really the simplest course in all these software engineering subjects. It's kind of like an overview of what you can expect here. We touch every maybe subject a little bit, like we'll touch the UML, the design a little bit, requirement a little bit, but later on you will have a more specific course on requirement engineering, like the modeling, the UML modeling, the object-oriented design, the testing. All of them will have a separate subject on that. And yeah, and it's really the easiest one in my mind. So you should have a very happy time in this class. And what else? Yeah, the other courses I taught, like the formal specifications and object-oriented classes, object-oriented course, object-oriented design. Those courses are some kind of difficult, have some kind of difficulty there. It's more difficult than this one, but this actually is more about giving you that mind to, like, maybe somewhat convert your mind from programming to engineering, change the mindset a little bit, to give you all those important ideas in your mindset. Okay. And what we can expect in this semester. Well, it's gonna be some engineering, introduction to software engineering, and well, it doesn't show it here. Then I will introduce the maybe software crisis. Every software engineering course starts with that. I don't know if you have learned that in the undergraduate level or not, but software crisis, and then we will learn the process, software process, and requirements, right? And the design, low level, high level design, how you're evaluating those quality control of your software, and some other future topic. Hey, on the future, maybe the future of software, something like that. Okay, now we have all of you here, 5 students.
I want to go on class.
Okay. Okay.
Sorry.
Yeah, that's why I show you this syllabus at first place. Yeah, make sure you're in the right one. Software engineering, right? Graduate level. Yeah, cool. Okay, so I was mentioning about this participation. Since we only have 5, I don't want to talk to the air, so participation is required. Unless you have some reason, you have to bring that to me maybe a week before that, and we meet every Tuesday, not Thursday. Okay, so Tuesday it's a hybrid class. Thursday we meet, and Tuesday we meet. Thursday you're doing this reading, assigned reading, all those materials online. All right. Okay. All right, that's about the introduction to this course. Not too much surprises, right?
You're recording every session, right? For online student has that, and we can access to the recording as well.
Yes. All of you have access to the same amount of material with online students. Yes. And this is recording, I think. Yeah, this is recording. Actually, I just directly broadcasted it to the YouTube channel, my YouTube channel. So if online student, you can find my YouTube channel, you can follow me, and then you can watch the live maybe. But I don't know how to share. I don't want to share that channel yet. I just want to upload. I just use that as a tool for the recording. Okay. All right, that's more about the introduction to this course. Any questions?
And does this course require programming or not really?
It's not very heavy programming. Maybe require a little bit, but not very heavy programming. Yeah. Yes. And other question? Questions?
So is there something new like every week?
Every week? Something new?
Something new.
Due? No, not every week. Well, there will be something due in during some of the weeks. Yeah, but not every week.
So we just have assignments and projects.
And exam, one exam.
Yeah, exam.
One midterm. No final. That's a good news. There's no final. Yeah. So the final is replaced by the final project. Yes. And the project is mostly the design, the documentation, those things.
Can we start even at like midway through the semester?
Yeah, through the semester.
Or the whole semester?
Well, the final project is actually, we separate it into several pieces. So you finish a chunk at a time. Maybe they're starting from some of the, maybe after the midterm. Yeah. And midterm is going to be online. Yep. That's the only exam.
Do you need that lockdown browser for it?
No. No. It's open note.
Oh.
Yeah. A lot of good news, right? Yeah, no term, open note, midterm, no final, open note, midterm, and project. That's where I want to see what I want to see, the skills you collaborate with the team, and the skills you apply those concepts to this design. Okay, we will touch a little bit about the design, but in order to have a good design, you need some other course to help you to follow the OO principles, to follow the design patterns. That's something else. But here I'm just telling you what are the design, what do they look like, and how can you make something that looks like a design. Okay, we go through the whole process to make something a little bit superficial, but we will dive into each one of them through your study. Okay. Yeah. Other questions? No? Pretty clear? Everything's clear? Okay. That means I did a good job explaining everything. Then we only have 5, right? So I want to know every one of you, because that's well, we will be here for the semester, for the whole semester. So let's introduce ourselves a little bit from left to right, from front to the end. Okay, that means you're the first. Yeah.
Hi everyone, my name is Jerusalem Morgan. I'm a recent graduate with computer engineering. I'm working on master's.
Masters of software engineering. Your first year?
Yeah, I just started this semester.
Okay, the semester. So you what's your like undergraduate?
Computer engineering.
Computer engineering. Maybe from here? Or-
No, Jackson State.
Okay, so between this undergraduate and now, do you have any experience?
So I worked on a startup called Cruise. It's like Uber but for long distance.
Oh. Okay, so are you still working there? What's up?
Not really.
So you're a full-time student? Yeah. Cool. And
My name is Shai. I got my undergraduate in computer science. I was in the military and Air Force for like 12 years. Computer engineer with Amazon. I just left there. Senior software administrator with DLH. And this is my second semester.
the second semester? Oh, I thought everybody's taking this course in the first semester.
I don't know.
No? I thought it's a prerequisite for everything. It's not?
Yeah.
It is? So what do you do in the first semester?
So when I started the first semester, and then I finished 6613. But during this course, my family, my dad and my sister were in a car accident, so I stopped.
Oh,
So
sorry
now-
to hear that. Sorry to hear that.
So it's like my 1.5 semesters.
They okay now?
Yeah, no.
Oh,
But we're back.
okay. Yeah. Sorry to hear that. But yeah, welcome.
Hey everyone, I'm Jin Zhang, and you can call me Apollo. I used to be a communication system designer, and my bachelor degree is automation. So actually, this is my second semester. I'm doing my master in computer science. I hope to learn a good way of thinking from this course.
So you're doing both? Like, you're doing a dual master?
No,
Or just computer science?
yeah, just for
I think he's doing computer science with some concentration on software engineering or right? Something like that.
no.
No.
So the computer science courses are more focused on the coding program and some application.
My name is Hava Anoni, and I'm a computer science student. This has been my last semester, hopefully. And so I'm looking for internship. It depends on my internship. Otherwise, I will finish in summer. And yeah. And my undergraduate was I got electrical engineering.
Electrical engineering. Double E. EE, right?
Yes.
Yeah.
Yes.
Cool.
And I didn't work so far, so I just moved here.
So you directly, after you graduate,
Yeah, I
from
finished my undergrad in my country, and then I moved here. I worked a bit for 2-3 years in a reseller company as a database, data entry, something like that.
That's
and
cool.
I thought, it's okay, I have to continue in computer science. It's very good major here. So,
nice. And
So my name is Maureen, and I'm doing my master's in software engineering. My undergrad was actually biology, so this is like something new I'm doing, like a career change.
no, that's actually awesome. We have 5 students, 5 different undergraduate program, right? Different undergraduate major. That's awesome. Yeah, it's the diversity, right? So you're doing biology. What makes you switch to this?
Well, I was doing a minor in computer
Yeah,
science
science.
in my undergrad, but I never finished it. And then I was gonna go to med school, but then I decided not to, and just to go to the tech area.
Okay, cool. So you give up. So that means software engineering is a better major than the medical, right? You think that way? Yeah, great.
I think it's like, I think you could do more with technologies and bigger impact, so.
Yeah. So everyone here, yeah. Good. So another question I have for you is your expectation, like not only from this program, your program, software engineering or computer science, but within your big expectation from the program, what is your expectation? Like, what do you want to learn? What are you expecting to learn from this software engineering, or you haven't think about it yet? Yeah, everyone. I mean, maybe you can talk about it.
The process, like the main process. I mean, coding is one thing, but
Yeah.
how one project can start.
Oh, cool. Yes.
That's what I'm expecting.
So yeah, that's something we can learn from here. Well, but today's industry is also quite different from company to company. Well, some of the company, they are doing a quite traditional way, like they're still doing some waterfall model, if you know that, the waterfall model. So okay, so they are doing a very old way because they want things to be quite reliable. But some of the companies, they are pursuing a very fast process to deliver their product to the market as soon as possible. So agile may be an option to go. So well, it's quite different. Yeah. So we will touch some of them a little bit here. Yeah, in this course, of course.
I
Yeah.
actually one question always I had. So I know computer science right now, so they more focus on the science, like machine learning, deep learning, cybersecurity, these kind of things. But software engineering, I need to know more about it. What exactly company needs for when they want to hire, they're looking for software engineer. What they exactly expect? What is the difference
Yeah, sometimes when a company hire a software engineer, they don't actually want to hire an engineer. They don't know what is an engineer. They just want to hire some programmer. They call it maybe software engineer. Well, okay, actually, as a software engineer, the technology, of course, is the basic. This computer science things. Maybe machine learning is a subject. Something else, programming is another area. Maybe machine learning needs to combine with programming, of course. And the data, okay, computer graphic. Each of them have different technology, different maybe language they preferred. Okay, and engineering, software engineering, I would say on top of that, it brings everything a level up. Okay, it's more abstract. So when we're trying to design, most of the time when we're trying to design things, we neglect what is the detail, the language we're using. Okay, when we have a design there, we can implement that with C++, C#, Java, whatever language there is, or maybe there could be a system that for the different module of the system, they build with a different language, right? That's pretty common today, especially for the web stuff. So they can just some companies they provide maybe Amazon, somebody from Amazon, right?
I work at Amazon.
Yeah, Amazon. Amazon they have a web service, Amazon Web Service, AWS, right? So okay, they provide all this maybe this calculation ability for you, the space, the virtual machine there. Well, when we use that web service to build our software system, the system actually includes their web service as a part of our system. But we don't need to care about the detail how they implement the web service. We just need to know the interface of the web service, and then in our end we use whatever language we are comfortable with to have this communication with web service. Most of the times some of the web service they can communicate through the XML stuff, just the interface to figure it out. And then different components of a system they can be implemented with different languages, right? So so here in the software engineering we actually bring everything a level up. So we want to control, what we really care about is the quality of the software product, right? The quality of the software product. So in order to have a high quality software, we want to the software to do exactly what the clients want you to do. Right? That's not something you cared a lot when you are doing the science stuff, like when I doing the programming, machine learning. Okay, when I doing the machine learning, okay, I care about this algorithm that solve that particular problem. But now we need to first figure out what the problem is from the client, right? That's the requirement. And also, after the algorithm is done, we design algorithm is part of it, and the algorithm works as a part of the system. We need a system. We design a system that including that algorithm as a part. And then we also evolving the system. How do we design a system? Okay, and then later on you have a system there. Later on, what if you want to change the system? If you do not plan for the change will be painful. I don't know if you have that experience. When you have a system built there already, even it's a small maybe course project, when the requirement changed or you want to change the system, make it better, usually it's hard because when you change one thing there, you touch a lot of other things which create a lot of new bugs. So that happens sometimes. So we want to try to avoid that from happening. So that's how we design for the change. We plan for the change. When we design the system, we know that in the future we're gonna maintain the system, we're going to change the system, so we need to keep that in mind. So we care about how do we design for the change, right? Like encapsulation, for example. Encapsulation is concept in the object-oriented programming. That means we put all the data, those algorithms, those details, encapsulate them in one module, so that the thing that talk to this module do not know all the details inside. But within this module, what you usually encapsulated is the thing that usually changed. Well, it's hard to talk about that without an example. Well, we will see that later anyway. But encapsulation is the thing that help you to manage those changes. Okay, so that's the level up. Okay, and then after you design your implementation, and then the testing, how do you do that? Testing is part of the software engineering as well. How do you verify? How do you verify that, okay, this system is whatever the customer needs, meet the customer's needs? How do you check? How do you verify that? Testing is not all about I check if there's bugs in the system. Bugs is one thing. Even your system is bug-free, it's possible that your system doesn't meet the client's needs because it doesn't do the thing. The client wants to do A, but your system does B perfectly. That's a waste of resource, right? So in order to do that, the verification, how do we verify? And to make sure we get the client's needs, sometimes we use technology as a specification, formal specification. That's that's a mathematic expression of the requirements, I can say, of the requirements of the design. So if you're using the mathematical language to do the design, the accuracy, there's no ambiguity. But if you're using another way, another option is you using a natural language to describe what the system is, what the system do. That can be quite confusing sometimes. Even when we're talking face to face, sometimes when I say A, you get the idea of B. That's possible, right? But with mathematical expression, that kind of problem can be limited, can be eliminated. Yeah. So that's well, kind of the difference I feel about software engineering and the computer science. I feel it's a level up. It's combined the details, technologies, those algorithms, and also the management, and also all of these subjects. It's make them combine them as an engineering subject. Like, how do we solve the problem? Yes. Yeah. Any other expectations, like you want to get from this course? You're expecting from this course? Well, this course won't. What this course won't give you is the programming skills. Okay, that's a freshman topic for undergraduates. So here, I understand some of you may not have a maybe solid programming skill. So I suggest you practice that. Use the time after not the class time to practice. This is not the class to practice the programming, but you can take other time to practice the programming. Well, it's encouraged because you cannot just be a software engineer without programming skills. Even you know all the concepts, you still at the end you still need to program things, do those things. Even you are
Code Academy, codeacademy.com is free. Walk you through basic programming.
Yeah, there are a whole bunch of resources like Code Academy, and some other resource. A lot of online courses teach you how to do the programming. That's basically a basic skill. Okay, like when you build a house. Okay, you are the designer of the house, but at least you should know how to stack all those bricks, right? That's some basic skill you need to know. Okay. Yeah. And when you are trying to find a job, like a software engineer who doesn't code, I don't know if that kind of thing exists. So yeah, you're highly encouraged to practice your programming skills. All right. Yeah, we have some student orientation tasks. It basically helps you to learn how to use the D2L. So there's some of the assignments like ask you to post something in the discussion area, like I'll ask you to teach you how to submit assignments in the attachment to the Dropbox. So please do that part after the class. Yeah. So I won't talk about that part. Okay. Yeah. Let's quickly go through these slides. Yeah, like I said, you should be able to have all this material. You should be able to find them, all of them, through D2L. Okay. Since this is like we have a half of the face-to-face session, so I highly encourage you to ask any questions, bring up any discussions to the classroom. Otherwise, it makes no difference than sitting in front of the computer watching the lectures, right? Okay, so talking about software engineering, what is software engineering? So it's software engineers uses computers as a tools for design and implementing a solution to a problem. Like I mentioned, we solve problem. Software engineering, we solve problem, and we have a whole process to solve that problem. We get requirements. We figure out what the problem really is. That is important. Okay, we figure out what the problem really is, and then we design to solve the problem, and we verify what do we solve the right problem, or do we solve the problem correctly? Yes. So analysis to the problem means, yeah, we really try to figure it out what the problem really is. And sometimes we divide the problem, we break the problem into different sub-problems, and we solve every sub-problems, and then we bring the solution together, bring the solution to sub-problem together to form a big solution to a whole big problem. Usually this solution is a higher level, like I want to manage the student course registration system. Student course registration system. Yeah, that's maybe the problem we want. We want to have a solution that can help manage all the students in the Kansas state. How do they register for course? Can you even imagine without this computer system, without networking computer system website and this database, how do we do the course registration without that? Like 100 years ago maybe. How do the universities at that time work? Well, it's very hard, right? Everything through the paperwork, and somebody has to verify that, check everything, right? But computer does give us these options, so we build the solutions, use this computer, use the tools on the computers. Yeah. So software engineers, as a software engineer, we use the tools, the techniques, and those procedures, yeah, paradigms to enhance the quality, keywords here, quality of the software solutions. So we focus on the quality. So what is the quality of the software? What is the quality? So here, okay. Well, here we have some explanation to other terms here. So method, technology, method or technique. So it's a procedure for producing a result. You can think it as a maybe algorithm, right? Tool. So we have well, give an example. So the tools. So we can have different tools to help us. Like when you are editing, you have a text editor. That's a tool. When you're programming, you have those IDEs, tools, right? And procedure. That's a recipe of combination of the tools and the technique. Yeah. And we also have the style of doing something. Maybe you are a little bit confused by these terms, but after this semester, I hope you have a more clear vision, more clear view of this. What is method, tool, procedure, paradigms of this whole software engineering? Yeah, it could be a little bit abstract. Yeah, it's maybe not that hands-on. When you're really programming something, okay, I know I manage the C language because I can use C language to solve this math problem. Yeah, but that's not the case in this course. This course is to refresh your mindset, to give you those ideas, to give you the vision instead of the skill. Okay. And speaking of the quality, what we really focus on, the quality of the software. So the outcome of software engineering should be a high quality software product. So here, well, we have some terminology for the quality. One's error, fault, and the failure. Okay, if you do not look at this explanation, how do you know that? How do you think the difference between those among this error, fault, and failure? What's the difference?
Error is it's human mistake, which human makes a problem. Fault is something it is in our program, like a bug. It has a problem. This part has a problem. It is in the program,
Yeah.
but it's not error. And failure, it's completely done. This fault makes a failure. This failure can stop any process of the software or something. So our aim is find these faults, which is error caused that.
Yeah. You're excellent student, because that's exactly what we're saying here in these slides. But if we take out the context here, take them out of this context. So error, fault, and failure, do they have a difference on the level? Like which one is more severe, do you think? Error? Failure? Yeah, severity.
Quite very.
What?
Very.
Very? Failure. Yeah. Failure is sounds like the most severe one, right? And fault, error. You can see it's increasing, right? From error to fault, from fault to failure. We have a difference in the level, in the severity, right? So, and we know from the intuition, we know that, well, error may cause the fault, may cause the failure. So, well, it's like small error. It leads to some bigger consequences. Okay, let's put them into the context here in the software. As a software here, the error, we refer that to some mistake, human mistake. Like we made some mistake when we're programming. Okay, we have a conversion error, maybe from the metric to English unit, something like that. We didn't take that into consideration in our system. That could be an error, and the fault there is the result of mistake. So it's in the system. When if we do not take that into consideration, the software product won't have the ability to automatically convert from the metric to English unit. Okay, then the system will make some fault. Like I'm asking what is the growth chart for a baby at 1 year old. If the baby is when my input is 23 inches, okay, and if you use that 23 as a centimeter in metric to compare with the other babies on the growth chart, you will get that baby probably it's gonna below 5%. Okay, when it's below 5%, the system will give you, okay, this baby is below 5%. That's the fault of the system, but it's caused by that error we made. Because when we implement the system, we forgot to do the conversion from English units to metric, right? And then later on, this failure, it means departure from the system's required behavior. The system is required to give you the correct percentage of that baby, the growth of the baby. However, you're not giving this correct percentage. So that fault caused the failure of the system. Okay, so the fault is more specific. The fault is giving the wrong percentage, and the failure is it's not giving the correct percentage, as the system may have another maybe functionalities. However, the system is a failure there. Okay, maybe we have more example there. How the arrow leads to the fault, leads to the failure. Okay, and more severe failure. We will see that in a minute. Okay, here is the chart. It says arrow can lead to the fault can lead to the failure. Maybe not all human error leads to the fault. That's possible, yeah. But it just says some of the error. They may all the way lead to the failure of the system. So we want trying to avoid this error fault. We want to have a high quality product. We don't want the product to have to fail. Okay, so in the software engineer, we will try to avoid the error from the human factors. Okay, and when we avoid that error, and when we're trying to design, we implement what we really trying to do in order to ensure we have a high quality system as much as possible. Yeah, and the thing is, there's no perfect way that you can build a system that is bug-free. No one can do that. But just we want to try to avoid them as much as possible with those methods. Okay. And the quality, different persons, different stakeholders, they have a different view, right? As a user, what do you think a higher quality? What do you think that is the quality of the product? Yeah, when you're using like a Facebook, for example, okay, how do you think, yeah, it's a high quality social network for you? More features?
More accessible, easy to work with that, quickly.
Yeah. So as a user, we think, okay, basically more features, probably the features we like, maybe not a lot of features that is nonsense there. Okay, more features, okay, faster access, and yeah, that's kind of the performance, but we do not actually care the performance inside, but we just want to feel it's fast. Or and also maybe the user interface is more friendly. It's we look comfortable. It looks comfortable to us, right? That's what we care about. That's a user, okay. But from the manufacturer, maybe from the manufacturer, not only the company, Facebook, and from the builder's perspective, okay. their perspective on the quality is more attached to maybe the specification of specification and maybe the functionalities, like when the product manager, when he is trying to see what is the quality there, he's more focused on, is that finish whatever I'm trying to do, what I'm trying to let you to finish. Did my team like actually put those functionalities in, and is this functionality correct? Is this system functioning correctly according to what we expect, right? And also, as from maybe an investor, those who invest money in this software product, their quality is more focused on, can this product bring me more money financially, right? And also, yeah, the budget. And from the product view, it's tied to the product characteristics and so many, because a software product, we have different rules as the stakeholders, users, manufacturers, the client, somebody who wants you to do this thing, and the manufacturer, the actual program, the project team. So everyone has different perspectives on the quality. So as a software engineer, we are trying to bring everyone in the stakeholders. As a stakeholder, bring everyone together. We take into consideration of all this perspective and solve the problem to deliver high quality. Here we say high quality. It's not only for users. The high quality doesn't only for users. It's also for the manufacturers, for the client, for the investors. It should be cost efficient, right? For the users, okay, I have a high quality product. It's user friendly. I use it perfect. However, it may be a disaster if like I want to ensure there's quick access. I have 1,000 of servers, thousands of servers, millions of servers there. So that's a disaster for financially for the company and for the investors, because that's just costs too much to deliver that friendly user interface, right? So that's where you consider that where you consider that as a high quality. Probably not. It's only high quality from a single perspective, from the user, but not all of this stakeholders, right? So when we talk about quality, that's from different perspective. Remember that part. Yeah. And this is system. Yeah, I like this part. It compares building a house with building a software. Well, they are engineer, right? And those who build the house, they are actually, I refer them to the real engineers. Well, they actually solve the problem. They have a solid product there, which is a house. But here, why we call the software also an engineering method? Why? Because, well, a lot of places comparable to building that house. For example, here we are actually borrowing some of the idea how the other subject, like house, the engineers, how they solve the problem of building a house. We try to borrow some of the idea to help us build a high quality software. For example, here, to build a house, first they need to determine, analyzing the requirements. What kind of house is this the owner want? Does the owner want? And maybe it's a ranch style, single floor house, right? So we have to analyze those requirements. How many rooms do you want? Yeah, like that's a house for living. And for different owner, maybe you're building a house, you're building a building for the military, for the military purpose. You are building a fort, which help you to defend in the war. So that you cannot just build with wood. Maybe you build with stones or even metal, right? So we need to analyze those requirements, and the software is the same. The requirement analysis and definition. We need to figure out what are we trying to build, and the producing and documenting the design. Yeah, and software engineering, we're also doing the documentation. Okay, and then we design the system. We design the house. Specify how do we want. We draw some blueprint of the house. In software engineering, we may have some UML, class diagrams to give you basic structure of the system. Here we have a basic structure of the house, and then after the design, we're going to in the house we're going to actually build those components and put them together. And here in the software, we write the programs in different components, as different components, and then we test each components and integrate them into one big system. And the house is the same. It build components, test components, integrating components. All right. And then we're making final modifications. Maybe some of the decorations, or something that we need to verify. Okay, there's a bug in the software system. There could be a bug in the, I mean not the bug, not the animal bug. It's the something we did wrong with the building. It's happened sometime, so we did some modifications. And at last, it's maintenance. We are all familiar with the maintenance of the house because it just costs a lot of money every year. For me, it's a pain. It's painful, yeah. But a maintenance of software, if it's designed pretty well, the maintenance should cost less. So the house, you think that actually, if it's designed pretty well, maybe newer house, well-designed house, it's easier. It gives you a lot of access to maintain some of features. Like if you have a problem on the roof, maybe it's easier to get on the roof. But if it's a very old house, it doesn't take those design into consideration. You have to try to, maybe you need to hack when you're trying to maintain the house. You need a ladder to access the roof somehow. The basement, you need to dig a hole to the basement. But if you design pretty well, I know that this basement is gonna have some problem, so I leave access to the basement, so I can maintain this thing easily, right? And software is the same. So if I'm planning for the change, I'm planning for, okay, so this part, it will have some problem in the future, so I just leave you access, or I plan that when I design that. It's gonna lower the cost of the maintenance. So that's a compare between the building a house and the software. Yeah. And here is the different rules in the software engineering. We have analyst, designer, programmer, tester, and trainer. They all take care of different stage of the process, right? I think if you have worked in that team, you know, sometime maybe you work as a designer and a programmer and a tester. That's pretty common. But when you work as a designer, programmer, tester, when you work in different roles, that you can actually have a different. Ideally, you should have different tasks to do. Okay, just not mess them. That's not perspective of engineering, software engineering method. But most time when we're doing our course project, we just write something. When we're writing, we're actually designing the thing. We do not have a separate design session for your program, right? We just think about it, start programming, and after programming, we try some of the test cases, then we're done. But here we are trying to say all of them should be a separate process in order to ensure the quality of the product. This graph is more clear. So what changed in software engineering is, well, all the things. the development of the technology that actually changed. So the computing technology, computing ability of maybe from the cloud, from the CPU, the fancy CPU, GPU, and this user interface change from maybe user interface actually changed a lot. In the beginning, the computer, you interact with the computer not through the keyboard, the screen, no keyboard, no screen. You interact with this tape. You have all those dots there. You give the input to the computer. The computer read the tape, like read them as a 1, 0, maybe something like that. I never use that because I'm not old enough. And but I hear that when there's no keyboard, there's no screen, people are using that to interact with the computer. Just input this 0, 1, 0, 1 with those dots on those tape. Okay, so you can imagine what kind of interface is that. But later on, we have a graphic user. We have a user. We have screen. We have printer. We can print something out, and then we have a screen. Even it's maybe a DOS system. I don't know if you even heard of that. Just type in those commands. It gives you some output as a text, right? And then we have this graphic user interface, right? Graphic user interface give you some fancy graphic as an output. Then we have some 3D. We have graphic card. We can have a 3D user interface, the virtual reality, the 3D user interface. So the user interface changed a lot. So it's changed. This technology changed, and well, we need the software engineering is changing accordingly to adapt to this technology. And also networking. Actually, that changed a lot. A lot of the architecture of the software. Now you can see how many things. Most of the software is maybe cloud-based. Yeah, you cannot even imagine what would you do with a computer if it's not connected to internet. But if you think about 20, maybe 30 years ago, 20 years ago, you can have a lot of fun with a computer even if it's not connected to internet. But now, maybe the fun is quite limited. So a software system, they're mostly distributed. You have a client part on your machine, but you have some part there on the cloud or on other people's machine. Interaction. So that changed a lot and changed the architecture of software in the software engineering, right? And time to market. Well, today the companies, you know how competitive it is, right? So, well, if they are doing social networking, probably there's no way for you to do social networking now because there's no space. All of the companies, they are working on that. Okay, we all think of some features at the same time. So what the customer is going to use is the first product maybe there, or the first high quality product that is there. And then we stuck to that product sometime. Yeah. And also, if we put something, do you think anything is missing here? For today's software engineering? The mobile computing part. Well, this graph, I think, is pretty old. This is desktop computing, but computing is increasing. Yeah, but desktop computing today, it's there, right? It's reaching the ceiling now, but the mobile, right? Mobile recently, it's also changing the software engineering. Okay, and this example. This is a failure, example of a failure of a software product. It's a rocket which fails. Let me show you how it fails. From this URL. This rocket did just explode, right? Let me highlight some of the part here. Just in the conclusion. So this rocket actually explode after maybe less than 1 minute after the launch. So what really happens at time is, let me show you here. What happens is this. So at this moment, the certain moment, the computer with the backup inertial reference system, which was working as a standby for guidance and the attitude control. The attitude control. Okay, you know what the attitude is? Attitude. Yeah, attitude here. Attitude control. Yes. Okay, so there is a backup computer there for the attitude control. Okay, the backup computer, it stopped working suddenly. It stopped working, and then it started to sending out all this random information, a random construction, random command. Okay, because that's a backup computer, right? The first computer is working correctly, and the backup computer is not supposed to sending anything, but the backup computer have some problem there, so it's sending some random message to the system. So the system think, okay, this backup computer is sending all this message, so that means the primary computer is not working. So I'm gonna take the message from the second computer, the second backup computer. However, the second backup computer is sending all those random message, which mess up all the system. But actually, the primary computer is working correctly there, right? So that leads to the final accident, the failure. That's a big failure. That is millions, maybe billions dollars failure, right? That's because of the arrow. The arrow. What is arrow there? The arrow is when we are trying to do the design, we should assume that if the first computer doesn't stop working, we should assume that there's no problem with this first computer, right? It just takes the second computer without confirming that this first computer is not is still working. So that's maybe something when we're design, we forget about that point. We should assume there's no error unless the first one stopped working. But this assumption is not there, which leads to the arrow. That the arrow is what described here. The computer takes the message from the second computer, backup computer, and the failure here is the whole project. The whole project failed. Yeah. And last thing here, I'll show you. So. Yeah, here this conclusion. The exception which occurred was not due to random failure, but a design error. So that's the conclusion. I want you to remember the design error which leads to the failure of the whole product. It's an error which may be a small error leads to $1 billion failure. So that's why quality matters. Quality matters to all the software product, and that's what we care about. That's why we care about quality in this software engineering. So through this master, we will learn the process that we're trying to preserve. We're trying to deliver a high quality software product as much as we can. Okay. All right, that's it for today. I will see you next time. Next time I'll see you is next Tuesday. Okay, and between now and next Tuesday, please go back, read all those materials in the Unit 1. Okay, and yeah, if you want to watch the lecture again, you can do it. All right, thank you very much.